Hello, students. Today we'll be working on the beginning of a new unit where we are working on simplifying radical expressions. Now, a radical is the inverse of taking an expression to a power. We're going to focus on square roots. So, taking the square root of an expression is the inverse of squaring an expression. So when I ask you for the square root of 81, I'm looking for an answer of 9 because 9 to the second power is equal to 81. So as you think about your perfect squares, so 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7, 49, 8 times 8 is 64, 9 times 9 is 81, and 10 times 10 is 100. If we were to do the square root of this top row, we would get the number that we took times itself to get our perfect squares. We also want to notice that any variable expression that has an even exponent would be a perfect square. So that would be x squared, x to the fourth, x to the sixth, x to the eighth, and so on. Those are all perfect squares, so that when you take their square roots, the square root would go away. We'll talk about what to do with that. We're going to look at problems today where we either have perfect squares or if they are not perfect squares, then we're going to simplify. We're going to do that by removing perfect square factors. And I've got a little procedure here for doing that, which I'll explain as we go through the process. So that actually is our first example. We have the square root of 24. Now, 24 is not a perfect square. So it's not in your list of perfect squares up here. So for the square root of 24, off to the side, we're going to do a factor tree for 24. And by that I mean we're going to start with our smallest number besides 1 that would divide into 24. Now that's going to be a 2. Some of you are going to need a calculator for this, and if you do, you're just going to have to go to Desmos and do that. But 2 times 12 will give you 24. Then we're going to see, does 2 divide into 12? Well, yes, it does. That gives you 6. We're going to look again. Does 2 divide into 6? Yes, and we get 3. And then 3 cannot divide by anything other than 1. We're not going to use 1 in this list. So we're going to rewrite the 24 as 2 times 2 times 2 times 3 inside the square root expression. So 2 times 2 times 2 times 3. These numbers here at the bottom that we have written our factors as. And then we're going to look to see, do we have pairs? Well, I have a pair of 2's. So I'm going to circle that pair. As I circle the pair, I'm going to remove it as a pair. So I'm going to remove it as a 2 and take it outside the radical expression. Then I'm going to rewrite my radical expression and leave inside the radical, multiplied together, anything that was not a pair and not circled. So 2 times 3 gives me 6. And this is what we call the simplified expression for the square root of 24. 2 times the square root of 6. Now, this same process that we used on the number 24 can also be applied to variables. So we have x to the 7th. Now, for variables, we don't need to do a factor tree. What instead we will do is we're just going to write out what x to the 7th means. So that means that we have x times itself 7 times. So there's 4, 5, 6, and 7. And then we're going to see how many pairs. So we have a pair of x's, we have another pair of x's, and we have another pair of x's. So as we bring our x's out, we have 1, 2, 3. We have 3 pairs. So we'll use that as our exponent, x to the 3rd. Then we still have an x inside the square root. So we're going to write the square root and keep the extra x inside of it. And this is the simplified version of the square root of x to the 7th. All right, so now we're going to do a combination of a number and a variable. So when you have a number part, 80 is not in our list. So we're going to start with the smallest number. So always check 2. Will this number divide by 2? And it does. It divides, gives us 40. We're going to keep using 2 until we can't use it anymore. So then we'll go 20. 20 can divide by 2. That gives us 10. 10 can divide by 2. And that gives us 5. All right, now you're going to need to write a long square root symbol because we're going to put all those 2's in it, as well as the 5 and several 6's. So 2 times 2 times 2 times 2 times 5, and then we have 6 x's. So x times x, x times x, x times x. We have 6 x's. We're going to go through and circle pairs. So we have a pair of 2's. We have another pair of 2's. A pair of x's, another pair of x's, and a final pair of x's. So for our 2's, we have 2 pairs. So 2 squared. We have 1, 2, 3 pairs of x's. And then we still have something inside the square root that didn't get circled. And so that stays. Now, in this case, we are going to look at our exponent on our number, and we can actually multiply that out. So 2 squared is 4. Then we'll have x to the 3rd power and keep our square root of 5. And that's going to be our final answer. 4 x to the 3rd times the square root of 5. All right, now we'll move along and take a look at number 4. Now, number 4, maybe you recognize 49. 49 is in your list as a perfect square. So you might be able to deal with that, and maybe you've picked up on how the exponents work. But if you don't recognize that, then a way that you can work this is just like we did for the others. You could take 49, and now 49 does not divide by 2 or 3 or 4 or 5 or 6, but it does divide by 7, and that's it. 7 won't divide by anything else. So as we write our square root, we will have the 7 and the 7. We'll have 8 x's. And we'll have 2 y's. All right, we're going to circle pairs. We have a pair of 7's, x's, another pair of x's, another pair, and another pair, and a pair of y's. So the 7 comes out, And then we have 1, 2, 3, 4 pairs of x's. That'll be x to the fourth. And we have one pair of y's. So that will be y to the first, and we won't write the 1 power. And notice that there is nothing left inside the square root. And so we don't need a square root symbol anymore. This would be our final answer. Okay, if you have discovered how to deal with the perfect square with the variables on a perfect square one, you may skip directly to this answer. All right. Another part of radical expressions is that they may be multiplied or divided and then simplified. So when you have two square roots, you can multiply the two numbers together. So 18 times 3, and if that's something you need to check out on Desmos, you can. So 18 multiplied by 3 would give you 54. And so this is the square root of 54. Then we'll do the same thing we did on the first part of this set of notes. 54, the smallest number is 2 that will divide into that. That gives us 27. And then 27 doesn't divide by 2, but it does divide by 3. 3 times 9. The 9 divides by 3 and gives us a 3. So we'll take that 54, and inside the square root you have 2, and then you have 3 3s. So we can circle this time a pair of 3s. So that 3 will come out, and then inside the square root we still have a 2 and a 3 that didn't get circled, and so that will be 3 times the square root of 6. And then this is our final answer, 3 square root 6. All right, in the case of variables, this will give you some review of multiplying with variables. So keep your square root sign. The 10 times the 5 multiplies to 50. X to the third times x multiplies to x to the fourth. So for the 50 part of this, 2 will divide and give you 25. Now, 25 will not divide by 2 or 3 or 4. It does divide by 5. 5 times 5 is 25. So we'll write our big square root and then have 2 times 5 times 5. Then we have x to the fourth. So 4 x's. We'll circle pairs. So we have these pairs of x's as well as the 5s. So 5 comes out. We had 2 pairs of x's. Those come out. And then we have a 2 left inside the radical expression. So 5x squared times the square root of 2. That is your final answer. We'll continue on even when you have multiple variables. You can keep your 1 square root. The 6 times the 12, again, if that's a little bit bigger and you don't know it, you can multiply. So 6 times 12, and that's 72. So 72, whoops. And then remember that for the x's, we add your exponents 3 and 5. That makes x to the 8th, and then y, 4 and 1, which would add up to y to the 5th. Now we'll take that 72 and break that down. So 2 and 36. 36 will divide by 2. That gives us 18. 18 will divide by 2. That gives us 9. Now, 9 will not divide by 2, but it will divide by 3 and give you 3. So, write your long square root because you have a lot to put in there. So, we have 3 2's and 2 3's. So, 2 times 2 times 2 times 3 times 3. We have 8 x's. And we have 5 y's. And that means we may need to make the square root line just a little bit longer. So pairs, we have a pair of 2's. We have a pair of 3's. And then our x's. We want to circle all those pairs. We want to circle all the pairs of the y's. So what we circle will come out. Now you can multiply the 2 and the 3 together, and that's going to give you 6. Then you have 1, 2, 3, 4 sets of x's. That's going to be x to the 4th. And you have 1, 2 sets of y's. That's going to give you y to the 2nd. And then inside the square root, we still have a 2 and a y. So inside 2y. This will be your final answer for simplifying that expression. And then we have one example of division. Division has other things that happen with it that we will not cover in this course. So we're just going to do a simple division problem. If you have 2 square roots that are both in the radical, you can divide the numbers that are inside. So in case you don't know that, you can always go to Desmos. 75 divided by 5. That gives you 15. And that division is staying inside the radical sign. So that becomes the square root of 15. If you're not sure, you can take the 15 and divide it, but it only divides by 3 and 5. Nothing could be circled, and so this would be your final answer. So those are your examples. You'll have a homework that's an Alex assignment. So good luck with your homework, and please ask questions as you have them.